Yeah, ko tēnā koutou katoa, ko Robin McNeill aha, and nice to be able to talk to you all today. And I'll just overcome a technical problem. There we are. So I'm Robin McNeill. I'm the Space Operations Manager at Great South, and believe it or not, I'm a rocket scientist, and I've got the best job in the world, I can tell you. I live and work in Invercargill, and for those of you who haven't been there, it's the very bottom, or the very south of the South Island. And we have a lot of fun there. As I say, I've got the coolest job in the world, and I'm in charge of the Aotearoa Satellite Ground Station. And what we do there is we provide all the telecommunications for scientists and rocket engineers and all sorts of other engineers to talk to their rockets and satellites. There's no point having a satellite or a rocket in the sky if you can't talk to it. And we get involved rockets. On the left there, we've got Peter Beck's Rocket Labs Electron. That's the smallest one we commercially involved with. And that's the Electron launcher. And that takes little satellites up in the top right-hand corner of my screen there. They're about the size of a loaf of bread, so they're not very big at all. They weigh about 2 kilograms, 3 kilograms. And then we go all the way through to the biggest commercial rockets in the world, which is in the middle, an Ariane 5 ES. And they take spacecraft that basically the one in the middle on the right-hand side, that's the size of a bus. And then we get involved with some little tiny rockets with the University of Canterbury on the bottom right-hand side there. And they go up anywhere from 400 metres to 4 kilometres. So yeah, that's very good. And of course, to do all that, we don't wave or send postage stamps or envelopes. We use antennas, and they can look a bit like on the left-hand side. And it's very much sort of like a sky dish or a Freeview dish, except it moves, and it's about, that one there's about 3.5 metres in diameter, and our biggest ones are about 5 metres in diameter. And instead of just a little set-top box on the screen, we've got computers and things like you can see on the right-hand side. Oops. And sometimes we have even smaller ones like you can see on the right. So there's a whole lot of people get involved. I'm not just doing all this work myself. I've got technicians and riggers, and you can see them working on an aerial on the left-hand side there. We've got crane drivers and builders moving antennas into place. And we've got builders like down at the bottom there. You've got to put the antennas. These antennas, the big ones, you know, they might be $1 million or even $3 million worth of value. They weigh quite a few tons. They move very fast. They've got to sit on a concrete base, and they have to be all engineered. So civil engineers provide all that. And so what I'm involved in is also, is just as well as building this infrastructure or being in charge of that, is actually flying satellites as well. Actually go up there and fly like a pilot, but we control them from the ground. And the little ones up the top left-hand corner, for example, they need to be able to download, and so we have to track where the satellites are, and we can do that using software like we have in the middle there, or the top right-hand side, which is a bit easier to understand. You can see a little circle around Aotearoa showing how far we can see. And then, unlike Sky TV, instead of seeing the movies, we see data, and that turns into information that other scientists will want to look at. And it's a pretty fun job. Up in the top left-hand corner, I get to go to conferences all over the world, and it's lots of fun. I've been up to the North Pole just about, looking at satellite ground stations, and there's really good reasons. You might wonder why sometimes, why that's a good place for satellite ground stations, and the answer is the same as why Aotearoa is really good. I've been on mock-ups of the International Space Station in the middle, and I've been on the mission control rooms. The one on the right-hand side is someone talking to Venus, which was so far away, it took like 3 minutes to get all the way to Venus, and then another 3 minutes to come all the way back. And also, what's also a lot of fun for me is I work with students, and I've got 2 PhD students that I co-supervise with the University of Canterbury rocketry group, Chris Hand's group, and that's a lot of fun too. And we're also involved with the University of Auckland with the Mission Operations Centre that we're building. So how did I get there? How do you become a rocket scientist like me? Well, I don't know if you want to be exactly like me, but Because I grew up in the Stone Age. I'm pretty ancient, and you can see the bike rack we had at my school, and I was one of the ones to have I was lucky to have a bike with round wheels, but you see on the back some of the other kids had old bikes with square wheels. But a bit more seriously, I grew up just between when the first satellite went up, Sputnik, 1958, and when Yuri Gagarin was the first person to go into space. And I was really lucky because my best friend's father was teaching at a university in Auckland, and he went over to America for a year, and he helped design the radios for the Gemini spacecraft. And I've actually met the guy who was inside that thing when it orbited and docked with another spacecraft. And that same technology was used in the Apollo missions to the moon, this was all in aid of. And that sort of got me really interested in radios, and I started about age 12, 13, making my own radios, and they looked a bit like this, a little 2 transistors you can see there if you want to know, and you can build these things. And then I got into ham radio with transmitters and all sorts of things, and I wanted to know how it all worked. How did antennas work? How did transistor radios work? How did radio work? And I ended up doing an engineering degree at the University of Canterbury, and I had a huge amount of fun there. And that set me up well for a career, and I was post office then, telecom, doing engineering. Also, I didn't stop. You never stop learning, even in this job. And I ended up working studying a degree in English at Massey University, because engineers do a lot of reading and writing, I can tell you, but more about that later. Other things you want to do. When I was at university, I wanted to play the viola in the National Youth Orchestra, which I did. Didn't do my engineering grades any good, but my viola teacher persuaded me to go to Invercargill, and that was one of the best things I ever did. More about that later. Anyway, I graduated, spent a year in London working on Apple II computers. The entire memory of that computer there that I had been working on is probably one small JPEG, but it was pretty advanced in the day. It was you could lift the lid and you were supposed to get involved with the insides of those computers. You still can, actually. And then I worked in telecommunications, taking what was called corded board exchanges. So in Southland at the time, there were a lot of telephone exchanges. They had manual operators. You didn't dial or say, hello, Siri, please call. You actually rang up a dial 0 or cranked up 0 and asked the operator to put the call through, just like Siri, except it was a real person. Or we had manual 2 motion switches on the left, made all those people redundant, and built computerized exchanges, which you can see on the right. That's not me, but not too far away. But also you've got to get telecommunications all over the place, and I had a lot of fun doing rural telecommunications. And in Southland, we live next to Fiordland National Park, and I put a link for telecommunications and telephone and data through to Milford Sound, and one of those, that link involved a number of mountaintop radio sites. You can see in the middle of the photograph, the mountain, Mount Pillins, just above the Milford track. And then you can see on the left-hand side, a little hut that I had to design and build and get the technicians to put equipment in, and radios and lightning protection. And you only could get there by helicopter. Even climbing up there with ropes was pretty serious. I never actually did that. And then later on, I worked for the United Nations in Tokelau, which is just up by the equator, New Zealand dependency. This is a more modern photograph, but those are the antennas on the left-hand side I was involved in putting in. I designed the whole system, the telephones, the phone book, the legislation, everything. I also worked down in Antarctica for a while, putting in the telephone system down there, so Scott Base can talk to McMurdo Base, and also for VHF radio and HF radio, so the technicians out in the, what was called out in the field, out on the white ice, could call home or talk to helicopter pilots or whatever they needed to do. And then I came back to Invercargill, and basically I'm now in charge of all the space operations in Southland. And I said I've got a number of technicians and engineers working for me. We look after all the really big names in the satellite world, SpaceX, Rocket Lab, you name them. They're all our customers. And we have people all over the world. Well, they have all been coming here, but the last one we had was just before COVID, level 4 from Italy, from Milan, which was a bit of a worry at the time. But so we're now having to do a lot of work without the help of the overseas people. We have to do it ourselves. So we use Skype and we have a lot of fun. Right, so if you're going to do all this, you need to have a few skills on what we do every day. Well, I live on the internet, and I live on my basically on my laptop. Without those two things, I'd be really stuck. And the laptop runs some amazing software now. You have to, for example, you can see here, I'm running some software to work out where the satellite's going to be and how many passes we can manage and when we can download data from that case as the spacecraft. It's about 400 kilometers up, doing 8 kilometers a second. So you've got to know where it's going to go to download it. Also, we do a lot of modeling with using a variety of languages, Python, C. I use Excel a lot, and I do a lot of working. But that's them, you know, the science, technology, engineering and mathematics. But this character on the right here is a guy called Mike Collins, and he was the third person in the Apollo 11 mission, and he was the one who stayed in the command module. He's still alive, and he's still very active, and he says you don't want just STEM, you put an A for arts in there as well, because, well, I'm prepared to believe him. He's a smarter man than me by a long shot, and if he says that's true, I'm prepared to agree with him. And also, I think that way anyway. So I read and write a lot of technical reports. You'd be surprised as an engineer how much reading you get to do. I also write books. I actually write all sorts of books and magazine articles, some actually on mountaineering and tramping, which is a good reason to live in Southland. I've got 4 engineers who have to work for me, and I've got contractors. I need to get them to be able to do what I want them to do. I can't beat them up, so I have to give them good advice. Even beating them up wouldn't work, of course. So look, what we have to do is give them good communications, good instructions, good drawings, good reports to work from. And it's a really great team we've got. And I get to talk to engineers and scientists from all over the world. I'm not very good at German, but we sort of sometimes get by, and I've got terrible French, and that's a big problem. So yeah, learning French, Russian, and German and Chinese might be good ideas, actually. And I have to give lots of presentations because lots of people are interested in space, just like now, I guess. And when I recruit engineers, I want smart, interesting people to be my team. I want people who can do more than just mathematics or more than just do modeling on computers. I want to know if they're interesting people. Do they play an instrument, or are they musical? Do they do speech and drama? Do they enjoy going into the mountains and tramping or hunting? Well, that's the South Island, I would guess, and the North Island surfing. Though we do surfing here. Do they like art, literature? I want to know if they're passionate about engineering. You don't want to do engineering if you're not really, really excited about it. But if you do software or experiment with electronics or do ham radio for a hobby, then that's really good. But we also want to know, you know, are you involved with clubs and organisations? Are you involved with your community? Do you belong in your community? And you can see I've got a few questions here. They were all set up for me to answer. And I was asked to provide one thing I wish I knew at your age before pursuing a STEM career. And the answer was, probably a bit surprising, I wish I knew that going to Invercargill would kickstart my career. I grew up in Papakura in South Auckland, and I did my engineering degree at Canterbury, and I thought the big cities was where everything happened. And much by accident, through my viola teacher, I found myself in Invercargill. I tell you, you'll have a much more exciting time working in smaller cities in New Zealand than you will in a big city, even with the big names. You'll get a whole lot more of different challenges, a whole lot of big variety of problems to solve that would otherwise be left to the specialists, and you can learn a lot. You go to the big cities afterwards. Another thing that you ought to know, girls make great engineers, and I can say that. I've recruited quite a few women engineers, and they're great. We had 5 girls from Southland Girls High graduate from engineering school at Canterbury probably 6 years ago now, and they're all fantastic engineers. Internationally, women make up about 30% of the space community, and that's growing, and the space community is really keen to have more women on board. So if girls, give it a go. And sometimes girls think that, you know, maybe law is where they feel more comfortable. In my experience in talking around, I think women get treated a whole lot better in engineering, in the engineering profession than they do going to law and probably even medicine. Women are really respected in engineering. At least all the engineers I know are very welcoming and enjoy having women working in the team and treated as equals, you know. Nothing special. You're there for the job, and we all solve the problems, and we're all there to have a good time. Right, so that's me. That's all the questions, and I hope you've enjoyed learning a little bit about what I do.
Robin, there are some questions in the Q&A box. Can you see those?
Okay. Renee asks, have you ever wanted to go into space? The answer is yes, and the answer is no. And the reason I've wanted to go, because I think it would be a fantastic experience and to be weightless. And the other thing is that being in space, it's a chance to see the whole world. Every one of the astronauts who went to the moon, they were more interested in the end about what they could learn about Earth than what they did about space. It was the first time with those Apollo astronauts they could see all the world at once. I mean, these days with science fiction and movies, we can sort of present pictures of what the Earth looks like, but before 1968, you couldn't do that. No one knew. And when the astronauts, every one of them came back from the moon, they just said how fragile the Earth was and how we have to look after and protect it. So I think that's a really good reason to go into space. Reason I don't want to go into space, one, and it's a big one, is that space sickness is a pretty serious problem. And I feel a bit funny on boats, and I think being space sick for 2 weeks in the International Space Station might just be a bit much for me, to be honest. So that's the answer. And also, Alex, what was it like in Antarctica? Well, it's big and it's white and it's pretty cold. They're not all wrapped up, so it's not as cold as it could be. When I was there, it was in October, there was hardly any animals to be seen. They were all way out of the sea ice was still in around Scott Basin at Murdo Sound, and so I saw some skuas, 2 skuas, and a whole lot of seals from a helicopter way up in the air, and they just looked like mouse droppings, so that wasn't too exciting. But it's a pretty good place to do science. It's the telecommunications problems are good fun. Working with the Americans and the New Zealanders is good fun too, and I can enjoy it. And Renee's got another question. What's been your favourite project to work on? I would have to say my current project. Whatever it is I'm doing at the moment is my favourite project. I can't believe that I get paid to have so much fun. It seems to me sometimes that I should be paying money to do what I do rather than to get paid for it. And it does pay pretty well, I can say too. But they've all got their own little things, but perhaps being in tow cloud, chugging across the lagoon with a briefcase in the bottom of my little boat with an outboard going off to see the Prime Minister has to be one of the quirky ones. But fishing in Antarctica on the day off, or making our first contacts with the Space Agency, or cutting over a new telephone exchange, they're all good fun. So, yep, whatever I'm working on is my favourite project.
Here's a wonder project question for you, Robin. Do you think there's life on other planets?
Well, who knows? And I guess one of the, I hope I'm alive to find out if there is any. You could argue that there's enough, and there's gazillion. There's more solar systems, I think, than there are, around the universe than there are sand in the world. So the probability of finding something somewhere, well, not necessarily us finding them, is, there is a chance. Whether we can communicate with them, that's another story. And I have to say, to be a bit pessimistic, any life form that's able to communicate with us has probably got to get through the nuclear and environmental age. And as some people have pointed out, the chances of a society getting so advanced that they don't destroy themselves before they get to the other side of either destroying the planet through the environmental degradation or atomic warfare is pretty remote. So, yeah, I'd like to believe that we'll do it, but who knows?